Hey everybody, I'm back and I got a new recording software. It's OBS, Open Broadcaster Software, and yeah, I'm starting a new playlist. It's called Math. It's not got an S at the end because that's incorrect. There you go. I hope you learned something already. Woohoo! Yeah, so I might be bringing a bit of VB into this. I might teach a bit of matrix. I don't fully understand matrices yet. I understand summation, I understand integral. Infinity is a hard one to explain, and people have different views on it. I understand I, which is the square root of -1. I understand the quadratic equation. I understand Pythagoras' theorem. I understand that, the roughly equivalent to symbol. And I understand the exponent. And I have created things on VB with relation to maths. But lesson 1, well, it's more just like, shouldn't be lesson. It should be more like a video. Oops. Video 1. Intro and algebra. So there we go, intro's out of the way. So let's get through boring algebra so that I make a mistake and then someone finds out all this rubbish stuff. Let me go through it because that's what I'm here to do. In both of these, A was common, so we could take it out and multiply it. In this one, you can take A up there, and then similarly you could take B out and replace it, so then you would have B times A divided by C. Here it's the same thing that went on over here, except for because we're doing division here. We're dividing this though. We're not doing A divided by B and C. No. We're doing A and B divided by C. So yeah, there we go. It becomes A, and then these two get multiplied. Then if we go over to what I just said, which is this, so now we take the brackets down, then we swap it around because A, anything, is just equal to itself divided by 1 divided by B divided by C. Let's pretend now that, yeah, let's just keep it like that, and then we go over to this equation we see over here, because it's basically, this is 1, and then this part is B, this part is C, and then because D, C, so it's AC, which is what we got up here, divided by B times 1, because 1 times B, same thing, so this is B and this is 1, so that's what we got right up there. Next we have these, so we have to find a common denominator, which is the underneath of a fraction or a division, and because we're using algebra we just multiply them because that's the easiest thing to do. Wow, okay, and then we just have to cancel out, so we do this times that, and then add them. Same thing here, except for you change the sign to negative. In this one, I have no idea how to explain this. You just have to take this one and understand it. It's just, you could split this up you could do what happens here and just split it up. So then you would have A divided by C minus B divided by D, and that still wouldn't make any sense either. But I went and researched and apparently that's correct. And in here, well, back with what I said here. Oh, 1 second. Back with what I said here, we find a common denominator, and that is going to be C, because there's nothing times C. And then that means that we just take that apart. The reason, first of all, why this can't be 0 is because then we'd have 0 divided by 0, because then all of this would become 0. Then we get 0 divided by 0, and that equals nothing, well, undefined. But basically what happens here is you cancel these out, so you can do, if you see the inverse of this, no wait, you do this, and of course if you can figure it out, because it's not that hard, you can do the inverse of this. So take these and it then becomes A times B plus C divided by A, and because it's multiply here, these cancel out and we're just left with B plus C. But again, saying that's along the fact that it doesn't equal 0. Well, actually that should be different. That should actually saying that A is a real number. And I think this is the sign that you use for real numbers. Oops, I did it incorrectly. But yeah, there's a sign which looks like a funny R, and it means all real numbers. And something like that. This one, oh yeah, never fully explained why this happens. But imagine this is 1/2, so 1 divided by 2. And this is, what else would it be? This was a quarter. And just saying, how many quarters can I fit into a half? So then you turn it around and you make this multiply, and then you swap the sign, so instead of it being C divided by D, you do D divided by C, and that technically just equals 4 if we were doing that's the quarter. So that would be 1, that's 1 and that's 4. So then, yeah, then I fell asleep. And you just multiply it basically. That's really it. 1 divided by 2 times 4, which looks similar to this one. Imagine that is 1 and imagine that is 2 and that is 4. So then it's 4 divided by 2, which is 2. That's correct because you can fit 2 halves into a 2 quarters into a half, not the other way around. There we go. Moving on. Quadratics, everyone's favourite. 5 and 6, they are number 2 and 3. So just because over here we swap the positioning of how they're multiplied, doesn't change the end result. So don't be fooled if you get a question like that and then suddenly a question like that. It's mainly the positioning of these inside the brackets. So what you would do for a quadratic is you would take that times this, which is a squared, and then this times the last one, which is AB. This times this, which is AB. BA doesn't really matter. It's like saying 4 times 3 or 3 times 4. It doesn't really matter. It only really matters if you have something like 4 minus 3 and 3 minus 4. Then it matters because this one equals 1, this one equals minus 1. So just bear that in mind when you're doing quadratics. So then you just get a squared, b squared. Because they're all positives, everything here is going to be positive. Everyone is positive. Happy? Right. Time to add negatives into this. So, positive a plus multiplied by positive a is positive a squared. Positive b times positive a is positive ab, which is this one. Positive a times negative b will equal negative ab. Positive b times negative b equals negative b squared. Then these two cancel out because they're the same. And no, they're opposite, sorry. And then we're just left with this. Apply the same rule, it's just this one's been reversed, but wait a second. It's the exact, because I told you about the multiplying thing, just change this around. And then this one looks extremely similar to this one. So then just take the answer of this one and swap the positions. So the position of B, the position of A here is B. So that means the position of A here will be B squared minus the position of B here will be A. So the position of all B's are A. Or you could just do it the big old hard way and have to get the entire answer. A and A, positive A, negative B and positive A is negative AB. Again, you do it again when you do this one and this one. So that's 2AB. And then negative times negative is the positive. And then, as I've said before, this looks like this one, and this looks like this one, so they would have the same answer. So then this one would be A squared minus B squared, and this one is B squared minus A squared. And yay! That's the end of the algebra one. Oh wait, no it isn't. I lied. Because that's what I did. Hey, that's meant to be. There we go. So, going into more stuff. So, if I did the square root of A, B, C, so these are all independent variables, and they're being multiplied. That is the same as doing the square root of A times the square root of B times the square root of C. So, let's use 100 as an example. So say we didn't know what the square root of 100 was. Just pretend. And if you don't know what the square root of 100 is, you're going to find out. What is 100 made of? It's made of 2 and 50. So there we go. The square root of 2 times the square root of 50. But wait a second, what's 50 made of? 2 and 25. Okay, so that equals the square root of 2, still containing this one, times, now what have we got here? Square root of this 2 times square root of 25. Now, what have we got here? Well, if we did the square root of a times the square root of a, it would simply equal a. And inverse to what we did here, if we did the square root of a times the square root of b, it would equal square root of a, b. I didn't do a that well. So, if we use this part over here, oops, that's the eraser, then this just simply equals 2. So then that equals 2 times, and the square root of 25, that's easy. No need to take it down any further, because that would be 5 and 5. So the square root of 5 times the square root of 5. Which, use this rule again, equals 2 times 5. Which then equals 10. So the square root of 100 is 10. Yay! I bet you probably all knew that. Now, to get even further in depth, let's say a was equal to, well, first of all, let's see what happens if we get a negative number, I don't know, negative 2, and we take a positive number. Same number though. So, square them both, and that equals 4, and that equals 4. That means that we can say that the square root of 4 equals both positive and negative 2. That's good and all, saying that square anything and it becomes positive. But if we make this negative? So we take negative 4. We don't know what that will be. It can't possibly be 2, because we know that becomes 4. And we don't have 4 in here, we have negative 4. And it can't possibly be negative 2, because that becomes 4. So if we decide to bring up a calculator and type in 4, make it negative, and then decide to, where's square root? It's probably staring me in the face. Square root, oh no, invalid input. So this is what mathematicians called the imaginary number. Now, unlike where we have to go, oh, what's 4 made out of? 2 and 2, okay. What we just do is we take the 4 out and multiply it by, well, negative 4 divided by 4 equals negative 1. So the square root of negative 1. And mathematicians called the square root of negative 1 I, standing for imaginary number. So then this would equal 4i. And that's the only exception to the rule. The square root of minus 4 is 4i. And I think that's the end of the video. There we go. Leave your comments and thoughts below in case I messed up somewhere here or here. And in case I forgot to add anything, there we go. I'll see you in the next video. Bye.